Okay, this video is a response to, I think it's question number 9 in lesson 6.5 in Math 172. Anyway, what you were given was a couple of pieces of information. You were told that the sine of alpha was this right here, this little 12/13. That was given. Change the color here, this. And you're also given this piece of information. The tangent of beta is -1 divided by the square root of 3. Now, in addition to those two pieces of information, you were also told that alpha is between -3 pi over 2 and a negative pi. So if I think about where that lies, negative pi would be right about here. Remember, if it's negative, we're going in a clockwise rotation. -3 pi over 2 is here, so our angle must lie in the second quadrant. And then with this tangent is equal to -1 over the square root of 3, and we're told that beta lies between pi over 2 and pi. We're looking at pi over 2 would be here, and pi, so our answer's got to be here again. For the angle beta has to be in the second quadrant. That's some information that we need to remember as we're working on these problems. Now, if I'm given the sine of alpha, back up here is the 12/13. Well, I need to go back and find out what is the cosine and what is the tangent of alpha, given the sine of alpha is 12/13. And I'm just using the relationship that sine is y divided by r. That was our definition for that. So I'm plugging back in to the equation x squared plus y squared is equal to r squared. That's the second part here. And so doing that, 13 squared equals x squared plus 12 squared. So I end up with 25 equals x squared. So I'm taking the square root of that. Now, how do I know x is negative instead of positive? It goes right back over here to this fact that it has to lie here in the second quadrant. So because of that, I'm going to use a -5 for x. So that tells me another piece of information. So I have this here, that the cosine is equal to -5/13, because r was 13. And then I can find tangent. And there's a couple of ways to do that. You can put sine over cosine. That's what I did. I just wrote it as that fraction and reduced it and got -12/5. Okay. So this would be our answer for tangent of alpha. And then when I go back down here to find the cosine and sine of beta, I use the same idea, that x squared plus y squared equals r squared. And for x, I'm using the square root of 3. Y is -1 because tangent is defined as y divided by x. And I'm going to clean that up, and I get r squared is equal to 4, so that means r equals 2. Now, as I'm looking at the problem here, since this terminates in quadrant 2, that means my value for r is going to be a +2 because the cosine in that quadrant is negative, which is negative square root of 3 over 2. And then the sine is going to be y over r, which is +1 over 2, because sine is positive in the second quadrant. So now I've got 6 pieces of information to work with. I know the sine, cosine, and tangent of alpha, and I know the sine, cosine, and tangent of beta. Okay, so let's move to our problems. Okay, so to do that, the first problem was to find the sine of alpha plus beta. Now, to do that, we have a rule, and our rule is the sine of alpha plus beta. That starts right here. This is our rule. Let me see what we can highlight that with. Sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. And all I'm going to do now is just make substitutions. You know, like I know the sine of alpha plus beta, so I'm looking at the sine of alpha. That was 12/13. The cosine of beta was negative square root of 3 over 2. The cosine of alpha was negative 5/13, and the sine of beta was 1/2. So I'm just plugging in, simplifying all of that, and that gives me this expression. Negative 12 times square root of 3 minus 5 all over 26. Okay. Now, with the cosine of alpha plus beta, that's part B. This is our rule. The cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. So here again, I'm just plugging in things. I know the cosine of alpha is this negative 5/13. The cosine of beta is negative square root of 3 over 2. The sine of alpha is 12/13, and the sine of beta is 1/2. And then all that simplifies to give me this answer, this 5 square root of 3 minus 12 all over 26. Okay, so that takes care of the cosine of the sum. Now the sine of the difference, this is part C of alpha and beta. It's the same thing, the rule is the same as the first rule, except here the SIGN between the terms is minus instead of plus. So we have exactly the same numbers, negative square root of 3 minus 5, a negative square root of 3 and 5, and then 26, except the sign here is the opposite of what it was in the original one. So this is our answer for the sine of alpha minus beta. Okay, and then the last part is the tangent, which is a little more involved. Let's see if I can get it all on there. Don't think I can. Anyway, the tangent of alpha minus beta, if you'll notice here, is this rule. Is tangent alpha minus tangent beta over 1 plus the tangent of alpha times the tangent of beta. So I'm picking up these numbers, this negative 12/5, the negative 1 over square root of 3, all that just comes from our previous work. So I'm plugging in those numbers for tangent alpha and tangent beta and using the appropriate signs, SIGNs here. And then I just clean this up. Get a common denominator of 5 square root of 3 for that numerator. And then I change this to 12 square root of 3 plus 5. And then for my denominator part, what I'm doing here is I'm looking at 5 square root of 3 plus 12, because I've got a negative times a negative, and my common denominator is 5 square root of 3. And since I'm dividing a fraction by a fraction, I'm just going to multiply by the reciprocal. So I'm flipping the denominator here, multiply that out, so the 5 square root of 3 cancels, and that leaves me with this as my answer. Now the only problem with that, it's not considered in simplest form because we have a radical in the denominator. So we've got to rationalize the denominator. Okay, so let me move up a little bit here. And we'll scroll up some. So I took the first part of the problem, and let's see if I can get back to something I'm marked with. Change that negative 12 square root of 3 plus 5. I just wrote it down as 5 minus 12 square root of 3. And the other one the same way, just wrote it as 12 plus 5 square root of 3. And use the conjugate of this part. So the conjugate for 12 plus 5 square root of 3 is 12 minus 5 square root of 3. So I've got to multiply both the numerator and denominator by the conjugate. And when I distribute through, use the FOIL method, our numerator ends up being 60 minus 144 times the square root of 3 minus 25 times the square root of 3 plus 180. And our denominator ends up being 144 minus 75. And then we're just going to add like terms. So this is our final answer for the tangent of alpha minus beta. I hope this helps.